Hello everyone, this is Bradley. Today this is a geometry nodes tutorial in which we're going to talk about how to offset the animation within geometry nodes. This term is very confusing, so I'm going to clarify. In case you're thinking, oh, I have a character rigging, like a walking cycle of my character, and I would like to instance my character, and different characters should have a different phase of their walking cycle keyframe. There's workaround to do that. Nevertheless, there is no direct way to achieve this function within geometry nodes. You have to use a workaround. The workaround is very simple. You just instance, you just duplicate your characters and then manually offset the keyframes and then instance with geometry nodes using the collection. So that there is a workaround, but there is no way to directly do so. Okay. Today we're going to talk about a different way thinking about the offsetting the animation. So I will firstly start with this kind of game, and then we will start to talk about how to achieve this kind of simple effect. So the game is pretty simple. So here we have 8 runners, and here is the starting line, and they are going to run across this finishing line. Okay. So basically a running race. So by playing the animation, we will see which runner is actually the fastest. So let's start. So we can see the first runner is very, very fast, but probably due to the perspective issues, the last runner is actually the fastest and crossing the line. Just move a few frames back. And we can see the last runner is crossing the back, and the third runner is the slowest, obviously. The first runner is the second place. Kind of a pity, but this is how the game works. So this is kind of very simple games, and by changing the random seed, everything will be changed differently. Like now the fifth runner is the fastest, and the last runner is not the slowest, but the second slowest probably. It's probably better if we change that to the perspective role so that we can actually see which one is actually the slowest. But anyway, you get the kind of idea. So this is what I'm going to talk about offsetting the animation. So you can see the different cubes has different movements, and there is more kind of settings we can on the top of that. For example, they start at different places. I didn't do that only because this is running race. How you can, you're supposed to have a difference. Actually, you can, because if you have the circular running track, you don't actually start with the same line. But anyway, that's not really matter. So this is just an idea. Okay. The whole point that I'm telling is that this kind of animation is possible in geometry nodes. So you do not need animation node to do that. Although I still recommend you to use animation node to do such kind of function, because I will discuss this in more detail later. But theoretically speaking, this is possible in geometry nodes, just to know. Even if you may need to use some horrible workarounds, but this is possible. Okay, so the answer is kind of clear. So I'm not sure if I'm going to build everything from the most beginning or other things. I think this is not a very difficult node tree. So let's just go through that step by step. Firstly, I have a line because to distribute all these kind of cubes. Okay. And the point of this distribute is after everything. So within the middle, whatever I'm trying to do, because we can ignore the finishing line, within the middle, whatever we're trying to do is to manipulate the locations and the movements of our points, and then we put our cubes on the top of that. Okay, so there are 2 parts within this entire setup. One is the destination. It's kind of very simple. You just determine where the final place that they should reach. Okay, so you have a number, a slider on the top of that. But before other than that, you need to actually separate this vector, because basically what you're trying to do is you have the original position. Okay, you have the original position at the starting line, and then you need to create a new vector, which is whatever called, for example, the destination. You can type whatever things that you just to know that you're going to create a new vector that defines their design's final location. Okay, here I'm just calling that P because it's the easiest to type instead of typing a long destination. Also be aware that if you type too long characters, you might cause typo, so that it does not work. And then the second part is kind of very simple. So talking about the most essential principle, which is actually the attribute mix. So if we do not worry about this entire middle ground part, just ignore everything, and we're going to use float. So the idea is that by changing this, we have the initial position and the end position, and by changing these factors, I'm moving my cubes from one place to the other. But this is very boring because there is no offset. It's just everyone just goes from 0 and everyone goes to 1. So they have a synchronized movement because you're using a single factor to control all these kind of cubes or points. Nevertheless, if you're using the attribute, then you can create a difference for each kind of cubes. It's just like different cubes have different positions. Different cubes have different P, so that different cubes can also have a different factor. So the whole point is, as long as you can create a difference in factor, whether you're using attribute randomize or using other methods, it does not really matter. You can have an offset of animation. So this is the whole principle about this animation. So here, let's just give you a kind of very simple example. So let's take an attribute randomize. We can use the float because actually the factor is float, and we can create or whatever. So take a factor. So immediately you have the difference in factors, you have the offset. But if you start from the 0 and then you increase this maximum number, then you can see different object is moving differently. So this is one way that you can animate that. Actually, you can directly keyframe these nodes. Does it show in keyframe? Hey, wait, why does it not show in my timeline? I don't know why. Anyway, probably it does not really matter. I'm not going to investigate in this case. Okay, so this is one idea. So you can offset this animation. Very simple, very quick. But of course, this is not ideal. That's why I added some more functionalities to that. So a little bit of bonus point talking about how to animate within geometry nodes. Basically, other than keyframe, I don't know why previously it does not work, but it should work. Another way is actually you can add a driver. So this is common knowledge within shader nodes as well. So if you take an attribute field, and you just type whatever attributes type, and within this socket, what you can do is you type I don't know how to call this symbol, and then you type a frame, then it will give you a frame number. So now this is 30 frames, it will type 30. So this is how you can animate across this entire timeline. Okay, you can add more functions. For example, within this driver, you can add divided by 100 or other things. There is one more step that you can go further, which I have done within this particular setup, is I linked to a frame end for the scene, so that even if I increase, why does keep disappear? That's why I hate this. If you add this frame end, this is the path for this. Basically, it just tells us the end frame of this entire animation, so that my attribute field will always reach 1. So even if I take the end to 500, at the end of frame, it will always reach 1. So this is a very interesting point. Okay. I think I will discuss this in more detail in the future, but this is it. Second thing is to add a variation, but I'm not going to use this because I hate to animate minimum and maximum separately. So I've discussed these presets in my preset release in geometry nodes. You can find the link in the description. I changed the name, but it does not really matter. So basically, you use the single value to animate the basic variation, and then you add a range. So by changing a single value, you're changing the variances. This will be implemented in geometry nodes in the future. I'm not sure if 3.0 will receive that or not, but this is a direction that geometry nodes is going towards but currently I'm making a preset of that, and you can change the seed. So basically, using a single number, you can add a variation instead of manipulating minimum and maximum separately. And by using a base number, you can actually animating the actual speed. And to combine these two attributes together, I basically using multiply. So that's the original factors multiply with a variance speed, you get a final result about how they actually goes. Okay, so by adding this base, you can see some of the cubes goes much faster than they should. Kind of idea. So this is basically all about it. So this is just a starting concept. Just to notice that I've made a preset talking about different fourth in the preset release as well. I don't have this in my startup. Do I have fourth? Yeah, I do not have. But this is also a way that you can put the fourth values within the factor. Also, just to mention that in practice, I never use geometry nodes to do these kind of things. I'm just saying that you can, and you can do a lot of variation on that. But in practice, I always recommend you use animation nodes because it's kind of easier. So let's get a little bit of comparison. So if I distribute linear, then I can have a different points within for this kind of object. So let's take the 8 and take the sides. Let's increase the size of our cube matrices. So I have 8 matrices, which you can think as a 8 objects. And by taking the offset matrices, so this is a node that directly do all this kind of function that we just have discussed. And by putting this while we're defining the last locations. Okay, but a very interesting part is by taking this random fourth. By taking different fourth, you can add different variances. And there is also another case that you can use a delay fourth and combine with a time info node. So like delay 2 frames and then put that frames. So now we can actually see how this object has a kind of delaying effect in their movements. All these kind of things can potentially be done in geometry nodes. Actually, they can. But considering about the simplicity of animation nodes in this case and the geometry nodes, you probably need to you need to manage all these kind of things. Okay, just to give you an example. But if you ask me if this is possible in geometry nodes, my answer is yes, this is possible. There's one thing I forgot to mention is if you play the animation. So firstly, let's increase the duration to like 80. Let's see how it looks, and you can see this animation is pretty linear. It's the points is hitting the end place pretty hard. Okay, so how can I actually smooth them? As I'm smoothing the keyframe. So there's the interpolation method. So you can increase the sinusoid or other things. So let's give you an extreme, which is exponent. So in this case, we can see this animation. So let's take it down to 50, I guess. So you can see, so the starts are slow, and it immediately speeds itself up, and then finally slowly reach the finishing line. It's kind of a beautiful movement instead of the linear movement that we see at the most beginning. Okay, and this concept can be used in geometry nodes as well. And also, one thing I forgot to mention: this concept can definitely be used for complex movement at some point. For example, just to give you an example, so there is a mirror interpolation. So mirror interpolation, basically what it does is originally just having a half of that. So it just goes from the start and to the end. But then now by mirroring, you just have another end. So this is just an example. It's really just an example. You always need to bear in mind that I'm just giving a kind of thought, but for details, you always have to think about yourself to make a variation and improvement. So let's play this animation. So initially it starts and suddenly it goes back. So this is a way for complex kind of movement. So for example, you can go up and down and other things. In this case, it just goes back and goes back, but you can make a complex movement in some cases as well. So this concept can definitely be done within geometry nodes as well, because we have the attribute clamp, attribute map range. Do we have attribute curve in 2.93? No, we do not have. Attribute interpolation? No, probably it's not in 2.93. So here we have this factor, and we can just map this factor. No, this is map range, so we need actually color ramp. So take this color ramp, take this factor, and remap to factor. So we have a white, which means 1, and then we have the black back again. So just a kind of example. Take that to black, and we need to manipulate this kind of data. So let's just take that to 80. So let's make the animation fast. So originally it reached, and then finally it goes back. So now you have a cycle. And by manipulating this linear, so instead of linear, we can use the B-spline, or we can use the ease. I think ease will be better, so we can see. So now it starts slowly, and finally end slowly, and finally go back slowly. So once we have once we are in 3.0, then there should be a curve node. So like a curve. Do we have that? I don't really remember. Anyway, so it's just a kind of idea. But you get a kind of idea by changing all these kind of values methods. So playing around with all these kind of settings. So I hope you enjoyed this tutorial. Probably see you next time. Bye bye.